Welcome everybody to Taking the Regents with Segelke. This, of course, is the Tuesday, June 21st Regents. Let me make sure my smart tools are working. They most certainly are. This Regents was the previous Regents, the previous June Regents, which for the most part was a fine test. I'll point out the questions that I thought were a little bit overly creative for their good, and therefore a little bit more confusing than they needed to be. But by and large, I think you'll see this is not a bad test. Well, let's go to it then. Question number one, an easy one, I think. It's asking the charge and the proton, the charge of an electron. You, of course, can go to table O and look them up for yourself. But, of course, I think this one is simple. Electron charge of -1, proton charge of +1. Number two, which subatomic particles are found in the nucleus of an atom of beryllium, or any atom for that matter? Don't let beryllium throw you off. It's true for any atom. Of course, that's neutrons and protons. Question number three, the elements in period 4 in the periodic table are arranged in order of. Now, what I can do, I can pull up the periodic table and show you just what they're talking about. Or at least I can show you it on its side. Notice here it's period 4. These are the horizontal periods. Now, if you notice, you can be misled easily here. You might think, oh, it's in terms of valence electron, because, yeah, I have 1 valence electron, 2 valence electrons. If you continue over this way, you'll see it goes 3, 4, 5, 6, 7, 8. You might think it's an order of increasing valence electrons, but remember, it's all about the atomic numbers. Atomic numbers are the organizational principle of this table. So we see that that's choice 2, atomic number. Which phrase describes 2 forms of solid carbon, diamond and graphite? Well, remember, guys, they are different. They're very, very different. Graphite, they're both carbon. However, graphite you can write with. Diamond, among other things, you can scratch glass up with. So they have, of course, different crystal and different properties. And of course, guys, we can say, diamond, you're beautiful like allotropes of carbon in the sky, like allotropes of carbon. Anyway. Number 5, which element has 6 valence electrons in each of its atoms in the ground state? If you go to your periodic table, you're going to see anything in group 16 has 6 valence electrons, and of course selenium happens to be in group number 16. Question 6. What is the chemical name for H2SO3AQ? Well, isn't there a table that lists all of the acids? That, of course, is table K. Why don't you and I take a look at table K right now? Here we are. They asked for H2SO3, not H2SO4. That's sulfurous acid. And sulfurous acid is choice number 2. Which substance is most soluble in water? Well, there is a table G, and you can compare relative solubilities, but if you notice, none of these are on table G, so you can't use table G. That's going to leave us with table F. Let me remind you how to go about that one. Sadly, I couldn't create a split screen, so if you notice, I had to take a moment and write out the 4 choices. Why don't we work backwards? What we're asking is, which of these is soluble? Well, we're looking for rules. CO3, recall, is on the insoluble side. Calcium is not an exception, so sadly, that's insoluble, so it can't be this one. AgSO4, there is a rule for SO4. Sulfates are on the soluble side. However, Ag is one of your 5 exceptions. So what was soluble now the exception is insoluble, so it can't be that one. CuOH2, is there a rule for OH? There is. OH is on the insoluble side. Is copper an exception to this rule? No, can't be that one. Well, by elimination, it has to be an H43PO4. Let me show you. You have 2 approaches. You could look for the rule for ammonium. Ammonium is on the soluble side, and there are no exceptions. So for that reason, it's soluble. Or You can look at the rule for phosphate. Phosphates are insoluble, but there are exceptions, one of which happens to be NH4. So either which way you go, you're going to get the right answer. So that, again, was choice 1. Number 8, which type of bonding is present in a sample of element that's malleable? Remember, my friends, malleable, I can take a hammer and whack, whack, whack. I can turn a piece of metal into a thin sheet. Metals are malleable, and metals are metallically bonded. Which atom has the greatest attraction for electrons in a chemical bond? I've told you many times, guys. You need to know the definition of this. Otherwise, it becomes maybe a difficult question. This is simply the definition, or at least that is, for what we call electronegativity. So the greatest attraction for electrons in a chemical bond means the greatest electronegativity. We can look up those values on table S, which I think you can find. Hydrogen is 2.2, oxygen is 3.4, silicon, it slips my mind right now. Sulfur is a lowly 2.6. Just take my word for it, my friends. Oxygen is the one with the highest electronegativity. Number 10, which type of reaction involves the transfer of electrons? Now, some of you are thinking right now, what about TICs? Does that help me? Transfer ionic. Well, that is true. In the formation of an ionic bond, there is a transfer of electrons. But which of these kinds of reactions involve the transfer of electrons? Well, it has to be this, redox. If you remember, in reduction, we have this term redox, the oxidation are the big losers. They lose electrons, and electrons are transferred from oxidation to reduction. Alpha decay is nuclear chemistry, has nothing to do with this. Double replacement, remember, has nothing to do with electrons. And neutralization is a kind of double replacement reaction, so therefore also has nothing to do with electrons. Number 11. Now you notice some figures and jottings and diagrams popped up on the screen. I like this question because there's more than one way to solve it. Let me show you what struck me first about it. A 10-gram sample of nitrogen is at STP. Which property will increase when the sample is cooled to 72 K at standard pressure? Well, remember, my friends, when you take a sample, here's my sample of nitrogen at STP, and it says we have 10 grams of gas. Now, when you drop the temperature, if you remember, that's also going to cause the following to happen. Because there is a decrease in temperature, we remember from our gas laws, there's also going to be a decrease in volume as we compress the molecules into a smaller volume. Well, it makes sense that if that happens, the mass stays the same, the volume decreases, you get an increase in density. Or you can think of it this way. They give you temperatures. If you go to table S and you look up the melting point and boiling point of nitrogen, it melts at 63 K. It boils at 77 K. So when it's above 77, it's a gas. When it's between 63 and 77, it's a liquid. If it's below 63, it's a solid. Well, if the temperature changes to 72 K, it means it's in the liquid phase. We know that a liquid is far more dense than is a gas. So those are two nice ways of solving that question. Which element is a gas at STP? Well, I would jump to table S, but it's on its side, so that makes our life a little bit difficult. Actually, let me check to see if it is. Oh, it was on its side. So what I did is I went and I looked up the boiling points of the 4 elements to point something out to you. You might have just remembered that xenon is a gas, and the other ones are solid. And that's great if you remember that. But if you forget that, you can use table S to figure out the question. Remember what I said? If the temperature is above the boiling point of the substance, that means that the substance at this temperature has boiled, meaning it exists as a gas. These standard temperature is below the boiling points of these 3. So that means these are not at a high enough temperature to have entered the gas phase. So we can eliminate these 3 from being gases, and we can establish that xenon is the gas. So you either could just remember that xenon is one of the group 18 noble gases, or you could use table S. Again, it's nice to have more than one way to solve the question. Fastest rate of reaction is all about getting the greatest number of collisions. Remember, how do I get the greatest number of collisions? Well, I can increase the surface area and increase the concentration. I think, we just happen to have hit the correct answer. Decreasing the concentration decreases reaction rate, decreasing surface area decreases reaction rate. So 13 is 1. 14, which process is commonly used to separate a mixture of ethanol and water? These are both liquids. We have two liquids that are what we call miscible. They're dissolved in each other. Well, the only way that I can separate two liquids is by exploiting their boiling point differences. Okay, so that has to be distillation. Number 15, an ideal gas. Remember, my friends, before long, you're going to take that Escalade down to Long Beach. I don't know if I told you, it used to be called Short Beach until they lengthened it. No, that's not true. Just made that up. Remember, there you are on the beach with your pretentious wraparound sunglasses and your pretentious crew cut and your pretentious whiter than white teeth, thinking this is ideal. By the way, a shout out to Mr. Segelke for coming up with this analogy. He's saying these are ideal conditions. The final exams are behind you. Therefore, you have very, very low pressure on you. And you have this beautiful 85-degree sun on you. So under conditions of high temperature and low pressure, you say this is ideal. Thank you, Mr. Segelke. Thank you. 16, the collision theory states that a reaction is most likely to occur when the reactant particles collide with the proper energy and orientation. Recall, if you have, let's say, H2, and you have Cl2, and you want to create HCl, these have to hit with the correct orientation and enough energy to break these bonds to cause that to go flying off. My friends, our friend Amedeo Avogadro said back in 1810, I believe, equal volumes of gas under the same conditions of temperature and pressure will have the same number of molecules, same number of moles of molecules. Very simply, if you see that you have 3 liters of H2 gas, you choose the volume that is the same of another gas, provided that they're under the same conditions of temperature and pressure. Easy question. The addition 18, the addition of a catalyst to a chemical reaction provides an alternate pathway that. Now, remember what happens is this is a very, very high bump of energy. It's like an energy barrier that we have to get over. Well, just in the same way that we would not drive over a mountaintop, we would decide to get some dynamite and blow a tunnel through the mountain. That's essentially the profile of a catalyst. So we want to decrease the activation energy. Remember, you do not do this. This is unaffected. Question 19. A sample of water is boiling as heat is added at a constant rate. So what I did here is I sketched a heating curve to show this in action. Which statement describes the potential energy and the average kinetic energy of the water molecules? Well, if the substance is undergoing boiling, as it is undergoing right here, notice the temperature stays the same. If the temperature stays the same, the kinetic energy also remains the same. So we can get rid of choices 4 and choice 2. Now, energy has to be changing. I'm pumping energy into this. Well, if kinetic energy is constant, then the potential energy must be increasing. So guys, this is going to be the extent of part 1 of taking the Regents with Segelke. Just stay tuned for the subsequent parts that will lead us through all 85 questions on this last year's Regents. Thank you.